Welcome to the DIY Honda Garage channel. DTC P0979 refers to a problem with the Shift Solenoid Valve C in Honda CRV models from 2011 to 2016. The issue signifies a short in the electrical circuit controlling this specific solenoid, which plays a critical role in the automatic transmission's operation. The solenoid is responsible for controlling the flow of transmission fluid, enabling the vehicle to shift gears smoothly. Located within the transmission assembly, its proper functioning is crucial for gear changes. Additionally, this code cannot be attributed to any mechanical issues within the transmission itself. It strictly pertains to electrical components. Before initiating troubleshooting, it is essential to record all freeze data and any onboard snapshot using the HDS, which refers to the Honda Diagnostic System, and review the general troubleshooting information for a comprehensive understanding of the situation. DTC P0979 signifies a malfunction within the Shift Solenoid Valve C, primarily indicating a short circuit issue. This solenoid operates electronically to control fluid flow within the transmission, and any electrical malfunction could disrupt gear shifting. The Shift Solenoid Valve C is specifically located inside the transmission, making it integral to the automatic transmission functions. An electrical fault here does not stem from mechanical breakdowns within the transmission, which means that any issues typically involve wiring or connections related to this valve. Hence, while troubleshooting, the focus will primarily rest on the electrical components that influence the solenoid's performance. Understanding that the error is electrical in nature helps streamline the troubleshooting process significantly. The potential causes of DTC P0979 predominantly revolve around electrical circuit problems. Short-to-ground faults can occur in the wiring harness connected to the Shift Solenoid Valve C, which can lead to unreliable operation of the solenoid. Additionally, the issue may stem from a faulty shift solenoid valve that does not perform as intended, thus triggering this specific diagnostic trouble code. When assessing the potential causes, it is essential to conduct thorough checks on the wiring and the solenoid itself, as these are integral to ensuring the electrical circuit operates correctly. Failure to resolve these problems can lead to transmission control issues, which may further complicate vehicle operation. Understanding these potential causes enables the technician to focus their troubleshooting efforts effectively. The symptoms associated with DTC P0979 usually manifest as noticeable transmission shifting issues. Drivers might experience delayed or harsh shifting between gears, which affects overall vehicle performance. The dashboard can display warning lights, indicating that there is a malfunction within the transmission system. Additionally, there may be instances of unexpected changes in gear, leading to an erratic driving experience. Such symptoms highlight the importance of addressing the issue promptly. Ignoring them can result in significant transmission damage over time. The presence of warning lights serves as an alert, urging users to seek diagnostics, particularly when paired with the symptoms of problematic gear shifts. Awareness of these symptoms can make it easier to identify issues related to the DTC code before they escalate into more severe problems. In this first troubleshooting step, the technician begins by turning the ignition switch to the on position, also known as position 2. This action powers the vehicle's electrical systems without starting the engine. Following that, the next crucial step involves clearing the DTC using the HDS, which refreshes the diagnostic system. Once the codes are clear, the vehicle should be test-driven in one gear for at least 1 second to gauge the operational status of the vehicle and check if the error reappears. It is essential to monitor any diagnostic trouble codes that may surface during this test drive. If DTC P0979 reappears, it confirms that the problem persists, and further steps outlined in the diagnostic procedures can be executed. This step sets the foundation for subsequent troubleshooting efforts. For Step 2, the technician must select the Shift Solenoid Valve C within the miscellaneous test menu on the HDS. This test allows for the functional assessment of the solenoid. Hearing a clicking sound during this test indicates that the solenoid valve is operating correctly, thus eliminating it as the cause of the DTC. If a clicking sound is noted, the technician can move on to Step 3 for further verification of the issue. However, if there is no clicking sound, this suggests a malfunction in the solenoid itself, warranting a deeper investigation. This step is critical because it directly tests the solenoid's functionality, making it clear whether the problem is localized to the solenoid or systemic within the associated wiring or electronic components. In Step 3, the technician needs to once again test drive the vehicle in first gear for a minimum of 1 second. This action helps determine the operational status of the automatic transmission. During this test, the technician must monitor the OBD status for DTC P0979 using the HDS. At this point, if the HDS indicates that the status is failed, it confirms that the problem persists, and the technician should proceed to check for loose connections or poor circuits between the Shift Solenoid Valve C and the Powertrain Control Module, PCM. If the HDS indicates passed, it may suggest an intermittent issue. Further checks may be required to inspect for any short circuits in the wiring. If the result is not completed, the technician should retest the vehicle to ensure all diagnostic conditions are met. This step is crucial in providing further insight into the DTC status and the health of the vehicle's systems. Step 4 entails several critical actions to check the internal resistance of the Shift Solenoid Valve C. First, the ignition must be turned to the lock position to ensure all electrical systems are powered off, providing a safe working environment. Next, the technician must jump the SCS line using the HDS, which is essential to bypass certain diagnostics. The subsequent step requires disconnecting the PCM connector C, which has 49 pins. Access to this connector typically involves locating it in the vehicle's engine bay or near the transmission. After disconnection, the technician measures the resistance between specified test points, reference point 1 within the PCM connector, and a body ground. If this resistance is less than 13.8 ohms, it indicates potential issues with the solenoid. The technician should continue to Step 5. Conversely, if the resistance is adequate, then Shift Solenoid Valve C is likely functioning correctly, warranting an update to the PCM software or substituting it with a known good unit for testing. In Step 5, the focus shifts to examining the wiring for short circuits. The technician is advised to disconnect the Shift Solenoid wire harness, specifically targeting the 8P connector. With this connection severed, the next critical task is checking for continuity between test point 1 on the PCM connector C and test point 2, which connects to body ground. The absence of continuity confirms that the SHC wire, which is the green wire integral to Shift Solenoid control, is functioning correctly. However, if continuity exists, it indicates a short to ground within the SHC wire between the Shift Solenoid harness and the PCM, necessitating repair. This step is vital in tracing the wiring back to ensure there are no faults contributing to the DTC P0979 error code, allowing for a more precise location of the issue. The final troubleshooting step, Step 6, involves a direct assessment of the Shift Solenoid Valve C itself. At this point, the technician must conduct a thorough test of the solenoid to verify if it operates as intended. If the Shift Solenoid Valve C is found to be in good working order, the next action should involve replacing the shift solenoid wire harness to eliminate any potential faults. Conversely, if the solenoid is deemed faulty, the technician should proceed to replace Shift Solenoid Valve C. This last step is essential as it directly addresses the root cause of the DTC P0979 and ensures that the transmission system operates smoothly. Following any part replacement, a repair verification process is needed to confirm that the issue has been resolved, which includes rechecking the OBD status. The final repair verification step is crucial to ensure that all previously disconnected connectors are reconnected properly. The technician must clear the DTC using the HDS once again to refresh the system post-repair. Following the clearance, the ignition switch should be turned to the on position with the shift lever in park position, allowing the engine to start and run for at least 1 second. A subsequent test drive in first gear for a duration of at least 1 second is necessary to monitor whether the error code reappears. Finally, checking the OBD status through the HDS will provide valuable insights into whether the repair was successful. If the HDS reports back passed, it confirms that the troubleshooting process has effectively addressed the issue. If failed, further investigation is warranted. This essential verification ensures the longevity of the vehicle's transmission performance. Preventive maintenance is vital to ensure the longevity and smooth operation of the vehicle's transmission system. Regular diagnostics using the HDS should be performed to catch potential issues before they escalate into serious problems. Periodically checking all electrical connections related to the shift solenoid is advisable, as loose or corroded connections can lead to intermittent failures. Additionally, keeping the PCM software up to date is crucial, as manufacturers routinely release updates to correct performance issues and improve reliability. Engaging in preventive maintenance not only enhances vehicle performance, but also extends its operational lifespan. Addressing these factors proactively can safeguard against common issues, providing peace of mind to the vehicle owner. In summary, DTC P0979 highlights specific electrical circuit problems with the Shift Solenoid Valve C in Honda CRV models from 2011 to 2016. Troubleshooting involves a systematic approach to verify the solenoid's functionality and inspect related wiring for shorts. This DTC primarily reflects electrical malfunctions and necessitates detailed checks within the transmission's electronic systems. Preventive maintenance plays a key role in ensuring the reliability of the transmission, encouraging regular checks and routine updates of the vehicle's software systems. Understanding both the identification and the implications of DTC P0979 can empower technicians and vehicle owners to take timely actions, ensuring a better driving experience and prolonged vehicle performance. Overall, timely troubleshooting can resolve issues effectively, preventing further complications down the line. Please like and subscribe to the channel. See you next time!